Question 8. So just set up your diagram. We obviously have the two tensions going upwards meeting at the pulley. We have a weight here of 0.3 G and a weight here of 0.4 G. And we basically, obviously it's moving, so we're going to use Newton's second law that F equals ma. So looking at B, okay, just looking at B only, we've got a net force upwards, so T's bigger. So our net force is T minus the weight, so minus 0.3 G, and that net force equals ma equals 0.3 times the acceleration. Now looking at A, we're now here because this pulley is going downwards, the weight's going downwards, our weight is greater than our tension, so 0.4 G minus T is the net force, F, equaling ma, so equaling 0.4 times the acceleration. Now remember, of course, this is taught, so the accelerations are equal. So we're being asked firstly to find the tension, so in order to solve this simultaneous equation we need to eliminate the acceleration. So I've chosen to multiply the first one by 10 over 3, the second by 10 over 4. That means they're both now equaling A, so I can make them equal to each other. G is obviously 9.8, allowing me, T is then therefore my only unknown, so T is 3.36 newtons. Now for part B, find the acceleration. Well, obviously the acceleration was the other unknown back here, so take an equation of your choice. I've taken the first one, equation 1. I now know that T is 3.36. Obviously G is 9.8, so it allows me to solve for acceleration 7 over 5 or 1.4. Now for part C, we're going to, when the particles have been moving for half a second, the string breaks, find the further time that elapses before B hits the floor. So think about what's going on here. So it's shooting upwards, this is B, it's shooting upwards. It's going to be handy for us to know how far it travels in this 0.5 seconds. And also we're going to need to know the speed it is travelling at after that 0.5 seconds. So we can do each of those one at a time. So first of all, we know that that T is 0.5 obviously. Our initial speed is 0. Our acceleration is 1.4, which we worked out just a minute ago, 1.4. And using S equals U plus V times T over 2, we can work out that the time that what are we doing? Yes, we can work out the distance travelled is 0.175 meters. Equally, using V equals U plus AT, we can work out that our final speed V was 0.7. So we know that at the end of that 0.5 seconds we're travelling at a speed of 0.7 and we've travelled a distance of 0.175 meters. So now let's go on to consider now straight after this 0.5 seconds. So we've got an initial speed, because I'm going to be resolving downwards. We've got or considering downwards as being positive rather, we've got an initial speed being the final speed that we've just worked out, magnitude 0.7, but that's going upwards, and I'm considering upwards to be negative, downwards to be positive. So my initial speed is minus 0.7. My acceleration gravity downwards positive 9.8, and the distance I'm going to need to travel is the net difference distance, so from here to here. So it's the height that I started at of 1 meter plus this extra little bit that I've travelled of 0.175 meters that I worked out here. So that's the distance, the net distance I will be travelling. So be careful though, you don't need to go and work out the distance all the way up to the top and all the way down again. You can simply just net the distance off. So using S equals ut plus half at squared, our only unknown is t. We can rearrange it into a quadratic looking like this, and then use the quadratic formula. We can solve for t. Two possible solutions, but one of them's negative, so we ignore that. given its time. So our one solution is 0.7 plus square root of 23.52 over 9.8, which is 0.566 seconds.